you can take to the bank. You can use the court of law, get something solid, something presentable, something scalable. It comes with those nice features. Get. I want to assume that you can hear me. Like I said, if you have a question, please call for my attention. I'm sharing my screen. So, yeah. So solid principle is a very important principle in OOP programming. There is object-oriented programming. Object-oriented programming. And for those of all of us are starting. So whatever the level, however high, however middle, however beginning, it's something that you see throughout. It's something that you see throughout. You get, and one of the things it helps us do, I'll say it's a mental model. It's a mental model. It might not be the solid principle itself might not be I would like to assertive. Yes, assertive, like you must do me, you must implement me. It's a mental model that shapes how you actually approach and write your code. You get. So solid principle, I believe it's an acronym, and I want to believe that we all know that. So the first step for single responsibility, as you can see on my screen, solid responsibility. Second step, open and close to open to extension but close to modification. Liskov substitution. When we get there, we'll see what it means. But Liskov substitution is basically saying a parent should be able to replace a child. A parent should be able to replace a child. Wherever a child is, a parent should be able to occupy our space. So that's Liskov. That's Liskov. We will get to understand that. We will get to understand about which that particular point. Because when you say a parent should be able to do what a child can do. Now it will make you wonder, like, because we are meant to know that OOP actually mirrors the real world object relationship, like parents parents to their child, you get. And now if you want to picture that particular statement, that particular scenario, they said the prayer of the parents is that the child should be able to do more than them. And now OOP is reversing that prayer, that the parents should be able to do more, and even exactly like you said. Yes. So as we proceed, we'll get to see what type of prayer OOP is praying. And then okay. Then we have interface segregation. Now this can be confusing even to the best of us. So I want to believe that, okay, there's just some certain level of understanding that would suffice to an extent. So we know it's not contradictory, it's very helpful and good. Interface segregation. And then we will talk about dependency inversion, which is one of the core principles of Spring Boot or Java development. Like this one is like, it's embedded in Spring Boot. You guys using Spring Boot. This is one of the principles. Spring Boot does not need to tell you, it does it. It just does it. So let's proceed. I'll be fast. In fact, within 30 minutes. Less than 30. So let's proceed. Okay, also we'll be covering like the single responsibility principle, open close principle, Liskov substitution. Subtype must be able to substitute. Okay, so must be substitutable for this type. Oh, we can see that I even inverted that. A subtype must be must be substitutable for base type. Yeah, that's exactly it. Must be substitutable for base type. So you can substitute and put the parent in place of the subtype. Interface segregation principle, many client-specific interface are better than one. Well, get this particular point actually interests me. We'll get to that point. So that's that, and then we have the dependency inversion. Depend upon abstraction and not concrete, not concretions. So let's proceed. Okay. Why solid principle? The cost of ignoring design principle. You see, like I said, the principles by itself is not an assertion. Like it's not forcing you or checking that you must do this, you must do that, you must forget it. It's not going to be that. But it's a mental model that should shape on the way you approach code. You get, like when they said this particular class should be closed to modification but open to extension. You yourself, you can write the code in such a way that for every update, you have to go into the code and change something, like modify something. And you can also adhere to a design pattern that just modified. Like, we have several more than 13, so strategy design pattern, refactor design pattern, observability design pattern, all the stuff. So these patterns are actually built up of solid principles because one of which you implement, it makes your code extensible to change instead of modifying a particular code. Yeah. So without solid, we have a rigid code, changes break on related features, they have fragile code. The code is very fragile, fixes cause new bugs. Immobile modules can be reused. You want to pack chunks of code inside of one class, lots of things. Like one class, you'll be able to do 10 people, the job of 10 people. I would say single responsibility. But not even just that, down to a method. A method will be doing 1 million people jobs. You get it? It shouldn't be. Yeah. Wrong approach is always easy. That's the truth. Wrong approach is always easy. Yes, like I could just write one smart code. You write a smart code that even yourself, when you look at it the next 2 minutes, you will not understand what you do. You get. So you want to take if you do not adhere to this particular principle. Yes, it might look tough in some certain pattern, but as you go, it becomes part of it. You get, and you enjoy what's that mental model gives up inside of the airlines. So because you now really, I've been stating this, you now really care about your code. You now really care about your code. You now really care about your code. So tightly coupled dependencies. So that's it. So without solid dependency, you might fall into the trap. In fact, not might, you will fall into the trap of tightly coupling everything. Everything just back and join. Again. So, but with solid principle, isolated changes, minimal risk, extensible new features without modifying existing code, you can get to just plug in new features without having to modify internal code to get this we do with interface and other patterns or other approaches. But interface, why it is debatable by the likes of Robert C. Martins and his likes and his conglomerates. Those guys are very incredible. Yeah, you always have something against powerful languages. Yeah, but yeah, interface is a very good one. Then we have the coupled and plugin usability, testable. It makes your code very testable. And then you have it is readable. Actually, imagine the class you write just does one thing. Your method does this method. Okay, this one is doing this one. This one is doing this. I just know that even the way your code like say the way your code comes together to solve one particular problem it, it can be very understandable if you approach it with the mindset of solid principle. For every method, this particular method does this one thing, this one does this one, this one does this one thing. Now you want to do, let's say, something, you want to host event, and you know there are different parts. So just pick this part, pick this part, pick this part, pick this part, and then you have the whole event. Okay. So Robert Timothy, you can see our favorite Uncle Bob here. For those of us that don't know Uncle Bob, the Uncle Bob, he wrote some clean code as advice. And
Hello,
yeah. Sorry, I said if you can speak, please. I'm not looking at my screen, but continue.
Are you displaying something on your screen for me?
Is that?
Like, are you displaying the slide or stuff? Like, I can't see the slide. It's only one paper I'm seeing on your screen.
One paper. Wait, are you seeing why solid principle?
No. Something like blue or ash color.
This with this. Very true. So is that the same for other people?
Yeah, it's just like the wallpaper we are seeing or something like that.
I'm just seeing one paper only.
This. Sorry, let me tell you this. Just okay. Let me share my screen. I think my blue screen. I can see it now. And I'm sharing my screen since.
Oh, okay, yeah, it's working out. Oh, okay.
So thank you for calling my attention.
Yeah, it's working.
Thank you very much. Okay. So this is this solid principle, like I said, is widely preached by Uncle Bob. Okay, let me move to the next. Okay, let's talk about single responsibility principles. Single responsibility principle says a class should have one and only one reason to change. Robert C. Martins. A class should have one and only one reason to change. So I'll come from this point here. A class should only have from the bullet point, you can see you have one class, one responsibility. Easier to understand, easier to test. Change in only one area, don't ripple everywhere. Promotes high question. So why the word literally should be understandable? You see go ahead and see some classes that does 1 million things. Now, but the thing is there is now an issue because all this your traditional layer pattern of approach where you have your controller, your persistence layer, your service class. Those are the three major layer structure that we have. Where you have those structure, those things let's say they are norms that have been over time has been adopted by many people. So there's also another type of architecture, which is the domain driven layer, domain driven architecture, I think. The domain driven layer, I think. Yeah, where the piano of that particular concept says a class, your whole package, your class should contains domain responsibilities. That means inside of your entity class, what that particular entity should do should be even in that particular class. That means you have a user class. Then what that user should be able to do should be in that user class. That's domain-driven architecture, I guess. No, but so far our traditional layers, we have our entity class separated from our service class, which is now specify what that particular user does, and so on and so forth, breaking down to the controller part. Now, if you come from those two different points, now you now want to clash the single responsibility principle. Now, what qualifies a class to what qualifies a class as a class that does just one thing? You get a class that does just one thing. Now, I would say it's at our discretion, but definitely it will become obvious when a class that does transactions, inside of that class, we can still perform other actions, like let's just say loan actions and other stuff. You get that becomes an obvious class that does not actually do one thing. You get that particular class do multiple things. Different. You can come into that class and see where they are making shoes, and also see where they are making ball and other stuff. You get. So this particular part now, like I said, it's a mental model. You get. And whenever you are writing a clean code, you should know and you should care. You get. Whenever you are writing a code, you should know and you should be particular about writing a clean code, that you know that even you yourself, when you come upon that code, you see this particular class, it's not jam-packed, it is doing one thing, and it only has one reason to change. You get. So that's at I would say at our discretion, you know when a class is actually going off the rails. You get, and you want to prioritize writing clean code. You make a code responsible. You make a class do one thing. You get, you make a class do just one thing. If you call it an entity class, that particular class should not be doing what service does. You get. Or if you call this class a product class, it should not be doing checkout. You get. So I'm just chucking that into our heads. What else? Let's move. So single responsibility, for example. Now you have your user service and your user, you get user void save to data. Then you also undo email inside of that particular service class, and you also generate reports inside of that particular class. You also generate reports inside of that particular class. But I'm sure most of the codes I've actually seen, you just see most of the I would say the service class I've seen, especially for you, that just contain, at least I would say people are doing right by that particular one. See, a service class just contain a CRUD operation for that part, for a user entity. You get create, read, delete, and other stuff. You get. So one of the things you want to do here is to separate those particular things. I'm sure most of the codes I've seen, at least people maintain this particular one. Probably is because it's easier to do. I think it's easier to just separate. Okay, this one goes here, this one goes here, this one goes here. And the layered architecture that has come to be the norms, it makes it even easier for us to practice. So key takeaway: split classes by responsibility. When you change email logic, it should never touch database. It should never touch database business logic. Yeah. You change a class should only have one reason to change. You get, not that you are changing something on database and it is affecting something else. You get, or you are changing database and let's say you make a change on database, it will affect the email. You make a change on logic, it will affect you make a change on the business logic or another class, it affects the other class. It affects another class. You get, that class that you've created should only change when you are changing something that has to do with that particular class. Single responsibility. So we have the open and close principle, which is famously open to extension but closed to modification. Open to extension, closed to modification. Software entity should be open for extension but closed to modification. Okay. Now this let's say we'll see that in our example. When you add new behavior to class, you don't have to. It means whenever you are writing your service method in your service, it means each of your method. If you've written a method that is where will fall, let's say where will fall let's say a trap of having to go into a method and change it, is when that particular method has broken the first principle. Because the truth about this particular all these principles is that they all have like their backbone upon the first principle. Like the first principle, which is a class will only do one thing. Now, if you've written a class that does many things, if you have already broken the first rule, then you find yourself actually breaking the second rule. Because now, if you want to, that particular class does 10 things, and you just want to change one thing, or you want to do one thing, you now go back to that, a method, let's say a service method. You now go back to that service method and change something. Albeit you have obeyed the first principle, which is single responsibility, then what you have is you have each and every of your method doing just one thing. Then it will be very hard. It will be. I don't think there will be a reason for you to want to change a method that just does. Okay, like let's say a method that only gets email, that gets the email of a particular user. It does one thing. There is no reason for you to change that particular class. There is no reason. But if it now has to do multiple things, then you now want to modify that particular class. So the mental model will be that each and every of your services, each and every of your service methods, if you can break them down to a point where they do one thing, you will hardly find a reason to want to modify them. You get? So don't alter tested working code. You get? Don't alter. And this is one thing that also affects when you find yourself in a code build that probably code build is not solid, and then you want to adhere to this particular principle. That particular code is actually the issue, and you don't want to modify the code. You get? It now boils down to discussion. I mean, if the code is wrong, you actually want to like touch the hell out of it. You want to press his neck. And this most of the times that I have experienced, not me myself, but I hardly talk to other people could when I see it. But most of the time when people do that, it's almost always people, maybe because I never see in national, but most of the time when people do that, it almost always lead to it almost cause a code to break at one point, because you don't know why the person is even doing this at the first place. Probably the person have done lots of mago and felt like this smart code is the solution. So you cannot, let's say, reverse engineer the thoughts of that particular person to actually get to that point. And then you come and then you break. And now coming back to you, the senior engineer as you are, you want to write a code that is so broken down that nobody really has a need to. They see that you really care about them, and they really do not have a need to actually modify the code. Like a code that we just call and it does one thing again. And let's give kudos to Spring Boot again. You see, whatever library you are using, you just like, okay, let's say for example, model mapper. just call your model mapper. You give it the DTO and the class, and it does the transition for you. Just one line of code. One line of code. That's what it abstracts the complexity, yes. But that's how also your code should be. You get? That's how your code should be. Your code will, when I see your code, I just call it just one line, and it's resolved. It abstracts those any layer that will make the code look like this. You put them in a very abstracted format. You get? So open and close principle. That your code should be such that it is well broken down. You don't really. I'm sure none of us have gone to a point where we might have done that, but I mean it's rare that you want to modify your modern mapper to do. It handles it for you. It handles it for you on very abstract level. You just have to just call it to you and then pass and then voila. Even though personally I do not trust modern mappers. I see the traditional mappers. But yeah, so open and close to people. You really do not want to modify your modern mapper. So example, you have the discount. Okay, I'm just go fast. You have the discount service. Consider this particular part. Oh, we can speak. Okay, you can see my screen. Consider this particular part of the code actually breaks the open and close open to extension, close to modification possible. Because you can come to this place and want to add hello, are we there?
No. We stopped hearing you at some point, so you can just repeat what you
Okay. Okay. So one of the ways you want to actually escape from this bad practices is use polymorphism and interface. Yes, use polymorphism and interface to, and I'm sure we have this a lot in our application. Use polymorphism, use interface. Adding a new discount type never requires touching the existing code for this particular part of our code. Just create a new class. You get? So, like if you have a class, if you have we'll come to this Liskov. Is it Liskov? Not Liskov, sorry. Something segregation principle. We'll come to that interface segregation principle. Well, we'll see why it is very important that you break your, instead of having a chunk of lots of methods, a lot of method inside of the interface that will not be implemented by whatever class is implementing it. You better break it to chunks and implement those multiple interfaces. It's not bad that you have multiple interfaces, but it will be bad that you have a method inside of your interface that a class that is implementing it does not need. Again, so for here now, you would have to, if you have something like this without interface, you have to if you want to change type, you have to come here and then edit the type. But for this, you just have for this second side, the right side, you have an interface that is implemented by this. Okay, you do discounts, double, and then if you want to make any change, you do student, you implement discounts, then you return a new type. You have a class. You have, for this one you have VIP discount, for this one you have student discount, for this one you have seasonal discount. You get? With this, you can implement that particular discount on different classes instead of just having this one discount class. And anytime you want to change, you have to anytime you want to change, you have to come into the code, and then you have to come into the code and add new. Yeah, you just come for this particular one that you just implement the discount on VIP discount on students on seasonal discount. But this particular one on the left side, you have to go into your discount service and now add the new type. You get this is what we call open to extension, close to modification. Yeah, you have to come into the code and then add the type. But for this one, you just extend. You get just add new. You don't have to change what is there already. Just implement that class already. You get. So, like when you go to your controller, it is the interface that you will now call. Then if you now want to use a particular interface, you can now use qualifier. You say, okay, qualifier, this particular one I want to use. I'm not going to use those already ones. So if at some point you don't want to use VIP discount, you want to use this particular one, just use qualifier to run that particular class to say that you want to get open to extension or close to modification. So Liskov substitution principle. Object of a superclass should be replaceable with object of its subclass without breaking behavior. Object of a superclass should be replaceable with object of its subclass without breaking behavior. So subtype must honor the contract, don't override or throw exception, designed by contract, enable true polymorphism. So it means wherever you see a parent, a child should be able to function there. Wherever you see a parent, a child should be able to function there. So for this example now, we have rectangle. We are looking at the left side now. We have rectangle and we have square extended rectangle. Square extended rectangle. Square and rectangle are not the same things. Square and rectangle are not the same thing. So that particular child, that particular subclass cannot they cannot replace themselves. They cannot replace themselves. But a rectangle is not a square, and square is not a rectangle. That's just the basic. That's just the basic concept. So that's just a concept. So it means when you are extending a class, when you are let's say both for inheritance and for interfaces, that you have a class, you how do I put it now? Your subclass have, or the parent have a character that particular subclass does not have. You get, and then you want to probably at some point assess that class that parent already have, and the subclass does not have it. It will throw an error. Get, it will throw an error. It will be an issue. So we declare that your parent have this, and then we'll come to you, and then we'll find out that you do not have it. So it will bring an issue. But for here now, we have shape. For the right side, we have a shape, and rectangle can inherit shape. All shape have areas. Rectangle can safely inherit shape. You get. Now for the left one, the formula for both of them is not even correct. You get, for rectangle and square does not match. But for shape, all shape have area. Square has area. Rectangle has area. So the subclass can safely replace the parent. The subclass can safely replace the parent class. So the key takeaway is that if a square extends rectangle, it breaks because of the weak behavior. But for shape, if a rectangle extends it can even replace, it can stand where the parent is because it has area in itself. You get? So we have interface segregation principle. Now this one is very straightforward. Very straightforward. I've explained it in the previous take that instead of, okay, let's say when you are writing your interface, when you are writing interface for let's say you create an interface of let's say square of a shape, or no, let me say interface of a bed, and the bed can fly in it, can fly in it, can walk in it, can jump in it. Now, a if a chicken extend that particular class, if a chicken extend that particular interface, it will be an issue because a chicken cannot fly. You get. So instead of doing that, what the principle of segregation wants you to do is to separate that particular interface, break down that particular. You can have two interfaces. You can have a flying interface that birds that can fly. That is, yes, birds that can fly. Is it birds? Yes, birds that can fly can extend that particular, can implement that particular interface. You get, without forcing a chicken that cannot fly to inherit it. You get, that's the core concept of interface segregation. So you should not just have one interface that have everything, and a class will now implement that interface, and it will now have properties that it itself will never use or it cannot use, because that's not what it does. You get? So split fat interfaces. Each interface should equal to specific role. Clients only implement what they need. Clients should only implement what they need. A bird, if a chicken should not be able to fly, then it's a reduce unnecessary coupling. We can see here, we have the worker interface, void, work, eat, sleep. Not everybody can work, not everybody can sleep, not everybody can eat. Like me now, I cannot eat. I mean, I can eat to the glory of God. But now, robots, they are also workers, but they do not eat. Robots, they are also workers, but they do not eat. So, where will you put them? Once they extend workers now, you see that it's an issue for them. Once they extend workers, it's an issue for them. So instead of that, you can just create workable and eatable, all those interfaces, and then human can work, human can eat, human can sleep. So you see what was it Robert Semantic, one of the captured previously. So it is better. It's not a sin to have multiple interfaces. It's not a sin. We can have as many. Java did not place a restriction on that. Java did not place a restriction on that. The only place they place a restriction is when you are doing inheritance, you are doing extend. Java does not support that, and the reason why is because of, they call it the diamond of death issue, where the probability of a child inheriting from two parents that also inherited from one parent is possible. And then if those two parents inherited from one parent and they override a method of that particular one parent, which of that method now belongs to that grandchild? Yeah, that's the concept of diamond. So that's one of the issues that multiple extension but so that's why they never allowed multiple extensions. So they just work with interfaces. You can implement as much. That's what the reason for interfaces, and you can implement as much interface as you want. There's no limit. There's no it is bad to implement 10 or 100. Yeah, even though I've not seen a class like that. If as a matter of fact, if you've checked many of any code base you've seen, you would have at least seen two concepts, and we wonder why. You get. So moving on, dependency inversion principle. Dependency inversion principle. This brings us to the last point. So far, I've said if you have a question, please ask. If I cannot answer, you will answer it by yourself. I'm just joking. So, dependency inversion principle. High-level module should not depend on low-level module. Both should depend on abstraction. Both should depend on abstraction. If you look at your code, you see your controller and your service logic, your business logic implementation. You see that they do not, that like, your controller does not directly depend on that particular service logic. As many of us have implemented, you have your interface that implements your that your business logic implements, and that's now what your controller service will now depend on. So in case you want to make changes in future days, you don't have to change anything on the controller level because it's not single dependent on the service. It's dependent on an interface. You now implement that interface, write your change. You don't need to change anything on your controller level. So it's saying a high level module should not depend on a low level module. Both should depend on abstraction. Okay. Depend on interface, not on classes. So that's high level control, low level via abstraction. Enable dependency injection. As I use listening, always interface almost every time. But also note, I think the last thought is not every time you want to implement interface, especially when you talk. You can do that, but it's still not every time you want to use interface. Yeah, but I say not they say it is good for testing actually, and because you want to do some, it gives you flexibility. Yeah, when you are testing, it gives you more flexibility. You want to create a costume. If you do a concrete implementation where you don't have an interface when you are testing. Now, let's say you want to extend from that particular you want to implement that interface on another way. You get, without interface you won't be able to do that. You get, that's why they say it's good for testing. You get, so I have kids. Apologies for the noise. Okay, so class management. Okay, so this the example of this thing. The example I just gave us is of controller. So your MySQL database, and then you have others tightly coupled to MySQL database. No, you don't want that. So what you really want to do is to have an interface, which we have in our database in our this thing. We have repository. We inject our repository into our service class. So you see that those repositories, they do not directly depend on themselves. They depend on abstraction, which is the interface. So that's. Is there a question? I'm almost done. Let me just. So solid, quick. Okay. Solid, quick reference. This is just a summary of everything we've spoken about. There's common mistake on anti-patterns. What to watch out for? God objects. And this God object, it mostly falls on these utility classes. Utility class, where you have a utility class that does everything and anything. You get, so that's also bad. You get, what else? Override through exceptions, endless if else. Yeah, you want to, for your if else, you can easily replace your if else with polymorphism. Yeah, polymorphism. Whenever you think if else, try polymorphism instead. You get, you got it. Okay, that will be a later discussion. So I just want to wrap up. Any question? Any question? I think this is my last page. So you want to master the 5 principles: single responsibility, open close, Liskov, interface segregation, and also dependency injection. So clean code always looks like it was written by someone who cares. Yes, robot C Martin, aka Uncle Bob. Any question? Thank you. Thank you. Thank you. So no question. Okay, that's good. I know solid principles is already in the heads of every one of us. That's why I choose the easy way out. I thank you for being an audience today. I appreciate your presence. So next Tuesday we'll be having a powerful session again. Have a wonderful night's rest. Enjoy.